What if I told you that everything, every galaxy, every star, every atom in your body, even the very fabric of space and time itself, all of it came from absolutely nothing? Not darkness, not emptiness, not some vast cosmic ocean waiting to be stirred. Literally nothing. No space, no time, no before. That's not a riddle. That's the single greatest mystery in all of science. You know, when NASA launched the James Webb Space Telescope, we thought we'd finally peek back to the edge of the universe's beginning. And we did. But what Webb can never show us, what no telescope ever built could possibly reveal, is what came before that very first moment. Because here's the mind-bending part. Before might not have even existed. Hey, welcome back to Space Secrets, the channel where we take the biggest, wildest questions in space and physics and break them down so they actually make sense. I'm so glad you're here today because this one is special. Today, we're diving into 10 of the most fascinating, most debated, most brain-expanding theories about what, if anything, existed before our universe was born. Stick with me all the way to the end, because these ideas build on each other, and by the final one, I promise your entire sense of reality is going to feel beautifully different. And if you love thinking about the universe's deepest secrets, go ahead and hit that subscribe button right now, because this is exactly what Space Secrets is all about. Let's go back before the beginning. Let's start with what we actually know. About 13.8 billion years ago, everything that exists, every galaxy, every planet, every party, and then, in an instant that makes every explosion in human history look like a quiet sneeze, it expanded. Rapidly, dramatically, and it never stopped. Clee of matter and every wave of light was compressed into a single, unimaginably hot, unimaginably dense point. And then, in an instant that makes every explosion in human history look like a quiet sneeze, it expanded. Rapidly, dramatically, and it never stopped. We call this the Big Bang. But here's where most people, even science fans, get it wrong. The Big Bang was not an explosion inside empty space, like a firework going off in a dark room. There was no room. There was no darkness waiting around it. Space itself was created in that moment. Time itself began there. The Big Bang wasn't something that happened inside the universe. The Big Bang was the universe switching on. Think of it this way. Imagine you're watching the greatest NASA launch in history, say, the Apollo 11 mission lifting off from Kennedy Space Center. You can track that rocket from ignition all the way to the moon and back. Every single moment is recorded, measurable, knowable. But what about the moment before the engineers even drew the blueprints, before the concept existed at all? There's no footage of that. There's no data. And with the Big Bang, it's not just that we lost the recording, it's that the recording device itself hadn't been invented yet. Even the James Webb Space Telescope, the most powerful space observatory ever launched by NASA, can only peer back to about 100 to 200 million years after the Big Bang. That's genuinely breathtaking as a space discovery. But the very first moments, the first trillionth of a second, remain hidden behind a wall of physics we don't yet fully understand, a period scientists call the Planck epoch. Beyond that wall, our current equations don't just struggle, they break. They produce infinities. They stop making sense entirely. And that's not a failure of science. That's science being beautifully, courageously honest about the edge of its own map. So if even our best tools and our sharpest minds hit a wall right at the moment of creation, the question that naturally follows is this: what, if anything, was on the other side of that wall before time itself had a name? So we've established that the Big Bang was the beginning of everything: space, matter, energy, and even time itself. But that raises a question so simple, so natural, that every curious mind eventually arrives at it. If time began at the Big Bang, what was happening before it? And here's where physics hands us one of the most quietly radical ideas in all of science. An idea so elegant and so strange that it doesn't just answer the question, it dissolves it entirely. Imagine you're standing at the South Pole, right there at the bottom of the Earth, at one of the most remote and extreme locations any American expedition has ever reached. Now someone asks you, what's south of where you're standing? And the honest answer is, nothing. Not because there's a wall, not because space runs out, but because south, as a direction, simply ceases to have any meaning at that point. You've reached the geometric limit of the concept itself. Stephen Hawking and physicist James Hartle proposed something remarkably similar about time. In what's known as the no-boundary proposal, they used the mathematics of quantum cosmology to suggest that time near the Big Bang behaves less like a straight line stretching backward into infinity, and more like a curved surface that smoothly closes in on itself. Just like the surface of the Earth has no edge, no point where you fall off, time may have no beginning in the sharp, dramatic sense we naturally imagine. In this model, asking what came before the Big Bang is like asking what's 1 mile south of the South Pole. The question feels completely logical. It's grammatically perfect, but physically, it may simply have no answer. Not because we're missing data, but because the concept of before stops applying altogether. Now, this isn't mysticism. This is grounded in serious mathematical physics, the same framework that helps us understand quantum mechanics, the science that underlies everything from NASA spacecraft electronics to the processors in your phone. And what makes this idea genuinely powerful is that it doesn't leave a void. It replaces the mystery of a missing past with something far more elegant, a universe that is, in the most literal geometric sense, complete in itself. But not every physicist was satisfied with an answer that made the question disappear. Some looked at the same mystery and said, "No, there was something before, and it was vast, it was violent, and it crashed into us." So what if time didn't simply curve closed and seal itself off at the beginning? What if something genuinely existed before our universe? Something enormous, something ancient, something that in a very real physical sense gave birth to everything we've ever observed or measured. That's exactly where 3 of the boldest theories in modern cosmology come in, and each one paints a completely different picture of what came before. Let's start with the inflationary multiverse. Back in the 1980s, American physicist Alan Guth at MIT proposed that in the universe's first unimaginably tiny fraction of a second, space expanded at a rate so explosive it makes the speed of light look leisurely. We call this cosmic inflation. Now here's the staggering implication. If inflation happened here, the math strongly suggests it didn't just happen once. It may be happening constantly, endlessly, in regions of a vast cosmic landscape far beyond anything NASA could ever observe. Bubbles of space keep forming, each one a separate universe with its own physics, its own constants, its own version of reality. Our entire observable universe, every galaxy Webb has ever photographed, may be just one bubble in an infinite, eternally inflating ocean. Then there's the Ekpyrotic Model, a theory that sounds almost mythological but is grounded in cutting-edge string theory physics. Imagine 2 enormous membranes, or brains, existing in a higher dimensional space. Think of them like 2 vast, invisible sheets floating parallel to each other. In this model, what we call the Big Bang wasn't a beginning at all. It was a collision. These 2 brains drifted slowly together across billions of years, and when they finally made contact, the energy released from that impact created our entire universe in a single, catastrophic moment. Before our Big Bang, in this theory, there was another universe entirely, ancient, cooling, dying, drifting silently toward its own end and ours simultaneously. And then there's perhaps the most visually compelling idea of all, the Big Bounce. In this model, our universe is just the latest chapter in an endless story. A previous universe expanded, slowed, and then, under the crushing force of gravity, collapsed back inward in what some call the Big Crunch, compressing all matter and energy back into a single dense point until the pressure became so extreme it exploded outward again. Our Big Bang was that rebound, a cosmic heartbeat. And if the cycle is truly endless, then before us there may have been universes stretching back through time without any beginning whatsoever. 3 theories, 3 radically different answers to the same question. And what they all share is a refusal to accept that nothing came before, a conviction that our universe didn't appear from a void, but emerged from something far older and stranger than we've ever imagined. But here's what all 3 of these theories still can't fully explain. Where did the raw energy, the quantum spark, the sheer physical potential to create anything at all actually come from in the first place? So we've explored universes colliding, cosmic bounces, and infinite bubbles of space. But every single one of those theories quietly sidesteps the deepest question of all. Not what came before our universe, but where did the raw material of existence itself come from? Where did the energy, the potential, the something originate? And this is where quantum physics walks into the room and says, actually, you may be thinking about nothing all wrong. Here's what we mean. In everyday American life, nothing means nothing. An empty parking lot, a blank page, a refrigerator at 2 a.m. with not a single leftover in sight. Nothing means the complete absence of everything. But in quantum physics, the branch of science that governs the behavior of the smallest particles in existence, nothing is not actually empty, not even close. What physicists call the quantum vacuum is the closest thing nature has to true emptiness. And yet, even there, particles are constantly flickering in and out of existence. Energy spikes and vanishes in intervals so brief they make a nanosecond feel like a lazy Sunday afternoon. This isn't speculation. This is experimentally verified, measurable, real. Researchers at Fermilab in Illinois and MIT have built entire careers mapping these quantum fluctuations. The effect even has a name, the Casimir effect, and it has been physically demonstrated in laboratories right here in the United States. Now scale that idea up to the most extreme version imaginable. Before our universe existed, there may have been no space, no matter, no light, but there may still have been a quantum vacuum, a seething, restless, probabilistic field of pure potential. And according to the mathematics of quantum cosmology, a universe-scale fluctuation in that vacuum isn't just possible. Given infinite time, or perhaps no time at all in any classical sense, it may have been inevitable. This is the heart of what physicist Alexander Vilenkin proposed, that the universe didn't just appear from nothing in a poetic sense. It may have literally quantum tunneled into existence, the same way a particle can tunnel through a barrier it classically has no right to cross. Our entire cosmos born from a fluctuation, a ripple in the void that never stopped expanding. Think about that. The same quantum mechanical rules that make your smartphone's microchip function, that make solar panels work, that allow NASA to design precision instruments sensitive enough to detect gravitational waves. Those same rules may be the reason anything exists at all. And yet, even this profound idea leaves one final, breathtaking question completely open. A question not about physics or mathematics, but about the very nature of knowledge itself, and whether some truths about our universe may forever lie just beyond the reach of human science. We've traveled a long way together in this video. From the edge of the observable universe, back through the Big Bang, past the moment time itself began, down into the quantum foam of pure potential. And now we arrive at the place every honest scientific journey eventually reaches, the frontier, the edge of the map, the point where human knowledge, for all its breathtaking power and beauty, looks out into the dark and says, "We don't know yet." And that is not a defeat. That is an invitation. Think about where we stood just 100 years ago. In the 1920s, most astronomers believed our Milky Way was the entire universe. The idea that those faint smudges of light visible through early telescopes were entire galaxies, billions of them, each containing hundreds of billions of stars, was considered radical. Then Edwin Hubble, working at the Mount Wilson Observatory in California, changed everything. He didn't just discover galaxies. He discovered that they were moving away from us. That space itself was expanding, and in doing so, he handed science the first real evidence that the universe had a beginning at all. That one discovery made right here in the United States unlocked decades of cosmological science that eventually led to everything we've discussed in this video. Now imagine what's coming next. NASA's Nancy Grace Roman Space Telescope is preparing to map the large-scale structure of the cosmos in ways we've never achieved before. Gravitational wave observatories like LIGO, with facilities in Washington State and Louisiana, are giving us an entirely new sense through which to hear the universe, ripples in space-time itself. and theoretical physicists at institutions across America are pushing the mathematics of quantum gravity, string theory, and loop quantum cosmology closer every year to a framework that might finally let us describe what happened at and before the Planck epoch, that wall where our current equations break down. Here's the honest truth about the question at the heart of this video. We do not yet know what existed before the universe. We may never know with certainty. Some physicists believe the answer is permanently beyond the reach of any observation, because by definition, nothing from before the Big Bang could have left a detectable trace inside our universe. Others believe the fingerprints of whatever came before are hiding in the cosmic microwave background, that faint afterglow of the Big Bang that NASA's WMAP satellite mapped with stunning precision, and that we simply haven't learned to read them fluently yet. But here's what I want you to hold on to as this video closes. Every theory we explored today, the no-boundary proposal, the multiverse, the Big Bounce, the quantum vacuum, every single one of them was built by human minds that refused to stop at the edge of the known. Scientists who looked at the most intimidating question in existence and said, let's think about this carefully. Let's follow the math. Let's be brave enough to be wrong and curious enough to keep going. That spirit, that restless, wonder-driven, rigorously honest pursuit of understanding, is the most essentially human thing science has ever produced. And the universe, for all its strangeness and scale, is not indifferent to that curiosity. It keeps leaving clues. Now, if this journey through the deepest questions in space science left you wanting more, then stay right here. Because next, we're going even further into the theories themselves, breaking down each one in detail so you can decide for yourself which explanation of cosmic origins makes the most sense to you. So let's bring it all the way home. In this video, we explored one of the greatest universe mysteries in all of science, and 3 ideas rose above the rest as the ones worth carrying with you. First, time itself may have had a beginning. Not just the universe, not just matter and energy, but time as a physical dimension may have simply not existed before the Big Bang, which means the question, what came before, isn't unanswered. It may be unscalable, and that's not a frustrating dead end. That's one of the most profound science facts any human mind has ever arrived at. Second, if something did exist before our universe, the leading candidates are extraordinary. A quantum vacuum seething with pure potential energy, a colliding membrane from another dimension, a previous universe that collapsed and rebounded into ours. These aren't science fiction. These are serious, mathematically grounded theories being actively researched at universities and institutions across the United States right now. And third, the honest, courageous admission that we don't fully know yet is itself a form of scientific progress. Every great NASA discovery in history, from Hubble's expanding universe to Webb's deepest space images ever captured, began with a scientist who was comfortable sitting with an open question. And here's what makes this feel personal. The tools being built right now, NASA's Roman Space Telescope, LIGO's gravitational wave detectors humming in Washington and Louisiana, the next generation of particle colliders, these are American-built instruments designed by American scientists, and they are aimed directly at these questions. The answers to the deepest mysteries of space exploration may come within our lifetime, possibly within the next decade. But here is the thought I want to leave you with tonight. Every atom in your body, the carbon, the oxygen, the iron in your blood, was forged inside stars that lived and died billions of years before our solar system existed. You are not separate from this story. You are made of it. And the fact that a collection of atoms arranged into a human being can sit here, on a small planet orbiting an ordinary star, and ask what existed before the universe itself, that might be the most astonishing science fact of all. The universe didn't just create matter. Somewhere along the way, it created curiosity. And curiosity, it turns out, has no boundary. If this video gave you that feeling, that quiet electric sense that reality is far stranger and more wonderful than it first appears, then you're exactly who Astro Matt was made for. Go ahead and subscribe to Astro Matt right now so you never miss an explanation. Every single week we take the biggest, most mind-expanding questions in space and physics and break them down with clarity, wonder, and the respect your curiosity deserves. New videos drop every week, and trust me, you don't want to miss what's coming next. Thank you so much for watching. I'll see you in the next one. Hey, thank you so much for watching this one all the way through. It genuinely means a lot. The idea that time itself may have had a beginning, that before the universe, might not even be a question physics can legally ask. That one still gets me every single time I think about it. And the fact that right now, NASA and scientists across this country are building the tools that might one day crack that mystery wide open. That's not just exciting for science, that's exciting for all of us. This is exactly why I love exploring these questions with you. The universe is so much stranger and so much more wonderful than we were ever taught in school. I'll see you in the next one.